This video is about how to make the unit circle. And I'm going to start off with what the unit circle actually is, because the word unit is essential to that. So here's a basic graph. And you have graphed coordinate pairs and various lines and things for a long time now. And you recognize that in general, unless you're told different, this is 1, 2, 3, and -1, -2, -3, just by units. And that's what a unit is. A unit is 1 unit. So the unit circle has a 1 unit radius. That's how, 1 unit. 1 unit, 1 unit, 1 unit. So it's a circle where the radius is 1. And so the unit circle that we're going to be studying in detail, that you have to actually make from scratch, is this small circle that has a radius of 1 in the middle of the big graph, every graph you've ever made. And in that one, this point right here, of course, has an x of 1 and a y of 0. And this point right here has an x of 0 and a y of 1. And over here, this point has an x of -1 and a y of 0. And down here, we're at 0, -1 for this point. And those are the first points that we will actually end up putting on our unit circle tip. So you can simply draw a big circle. I'm going to use a circle I've prepared that's a lot better than the circle I would draw by hand. And we would see that right here is the origin. So this is a coordinate graph. We're just stopping at a radius of 1. So right here, that's 0, 0. And over here then is the point, let's go like that. It's the point 1, 0. And up here is the point 0, 1. And then we're going 1 this way, but this is into the negatives of the x values. So it's -1, and this is the line y equals 0. This is the line x equals 0. So we're at 0 for the x, but now we're at -1 for the y, because the y's are negative here. And just like normal, all of the coordinate points here are positive for the x values and positive for the y values. And over here, I'll put it in a little coordinate point form. And over here, this is negative for the x's, because any point over here will have a negative x and a positive y. And down here, they're both negative, because the x is a negative and the y is a negative. And over here, the x is a positive and the y's are negative. And so when we put a few points on here, you have to pay close attention to whether they're positive or negative. That will come back in many, many, many problems in the future in trigonometry. Right. Now, the degrees that are here, you know that a circle is 360 degrees. Well, this point here, we always start here at 1, 0 for our points for the degrees. It's 0 degrees right here. It's also 360 degrees, because it's 1 full turn around. So this point has 2 names. When you write the graph for me, you must include both of those. You don't need to include plus, plus, minus, plus, minus, minus, plus, minus, or even 0, 0. But I do want the points that I tell you need to be here on the outside. There are actually 17 points. You'd think 16, well, 16 points, but because I want this for both of them, you have to give me 17. And we know that this is a right angle, so right up here is 90 degrees. And then a straight line makes 180 degrees. And when you do 3/4 around, 3/4 is 75%. And of 360, that means this is 270 degrees. Now let's come back to the first quadrant. And half of 90 degrees, if I go exactly halfway here, and it looks like close enough to halfway, half of 90 is 45 degrees. Now, let's do those halves on each of the quadrants. If I go half here, halfway between 90 and 180, is going to be 135, and you can also think of it as 45 plus 90 or 45 less than 180. Looking at it closely, I guess I should have put that about here, but this is reasonable enough to count. So this one is 135 degrees, and halfway here I think is about here. I think I did a little better at getting it halfway, maybe not. And 45 more than 180, or 45 less than 270, right in the middle between them, is 225 degrees. And over here, same thing. And now this amount comes to 315 degrees if you add 45 or subtract 45. Those 4 points all have many similar characteristics, especially when we do the x and y points in a few moments. But let's come back up to here. The other ones we need to include are 30 degrees and 60 degrees. So I'm reasonably close here, I think, with where 30 would be, and then 60, and then 90, because really we're taking this quarter and we're splitting it up into 3 parts. And that's how you can get 30, 60, and 90. And then we also have to do it over here on these. Now notice I'm completely ignoring the 45 for that, because here's 1/3 of it, 2/3 of it, 3/3 of the quarter. And we just skip that one, because the 45s don't have the same relationship to the 30s and 60s that the 90s do, or whatever. There's a completely different relationship. So this one's 120 degrees because it's 30 more than 90, and 60 more than 90 would be 150 degrees. Now let's talk about that one for a moment, because this 120 I said is 30 more than 90. Yes, it is. But the better way to think about it is that if you're on the x-axis and you're coming up to it, it's a 60-degree angle here. That's called a reference angle. The angles that come up from the x-axis or down from it are reference angles. And so 120 degrees should be thought of more as a 60-degree reference angle than it should be as 30 more than 90. So it's 60 less than 180. Part of that is because the 120 degrees shares some characteristics with 60 degrees. It also shares characteristics down here with the equivalent 60-degree place, which is 60 more than 180. As opposed to thinking of it as 30 less than 270, it should be thought as 60 more than 180, which means this one here is 240 degrees. And if we go and do a 30-degree reference angle, 30 degrees from the x-axis here, this one would be 210 degrees. And over here we do the same thing, where to get the number for this, adding 30 to 270 really is the easiest way, but that really means 60 less than 360, which is pretty easy also. And then over here we have 330, and now we have all the degree points. So there are essentially 4 here in this quadrant, 4 in that one, 4 in that one, 4 in that one. That one's a double one. So I count that. Or you could think of it as this one and those 3, or this one and those 3. It doesn't really matter about the quadrantal ones, because they could go either way. But point is that there are 16 points and 17 numbers you need to put for that. All right, now let's look at these things. We have the x and y points for these, but we also are going to do the x and y points for the 30, 45, and 60 degrees. So let's identify what those are. And I'm going to give myself some room to put them. Okay. So this is where I'm going to write in what the x and y points are. Now, I could make a little guess, because 30 degrees here, the x value for that point, that particular point on there, where the 30-degree angle goes out to, that point is about here, and that looks like it's like, 0.8 or so. This is 1.0, so that would be like 0.8 or so. And over here, if you go over here to the y-axis, it's almost like exactly half, as if it's like 0.5. Because of the 30-degree angle, we can find those by coming down here. We're going to use the right triangles that are down here. And here's part of why. The x value for each of these is the cosine of that degree, and the y value is the sine. Up here I'm going to write that as a reminder. Cosine, comma, sine. So if I know the cosine of 30 degrees, that's the x value. The sine of 30 degrees would be the y value. So let's come down here and take a look at the triangles. One of the things that you have already learned in trigonometry is that the relationship between the sides for a 30, 60, 90 triangle has this ratio of 1 to the square root of 3 to 2. So if this was 5, this would be 5 times square root of 3, and this would be 10. Or any number you put for the small leg, times it by square root of 3 to get the large leg, and double it to get the hypotenuse. Well, here is 30 degrees, so the sine of 30 degrees would be the opposite over the hypotenuse, which is 1 over 2. Now I can come right up here and I can write 1/2 in here. You can write it as 0.5 also, but you'll see it's very common to leave it as 1/2. So I'm going to do that right now. The cosine of 30 degrees is going to be the adjacent over the hypotenuse. So it's square root of 3 over 2. That is going to come up here and go in as the x value. The actual decimal of that you could figure out, but that's not our purpose here right now. And because the decimal is a never-ending, never-repeating decimal, you'd have to round it off. This is an exact answer, and as soon as you round it, it's not quite exact anymore. So we're going to leave it in the square root form. The 60 and 33 have a special relationship here because they're on opposite parts of this same triangle. So the 60-degree sine, if you do 60 degrees and you do the sine, you're doing opposite over hypotenuse, which is square root of 3 over 2, which actually is the same as this. So I'm going to go here and say sine 60 degrees. So the sine of 60 degrees is square root of 3 over 2, just like the cosine of 30 was. Let's come up here and actually put that in there. Now, look for the sine. The sine, oops, did I make a mistake? No, I didn't. The cosine, that was the sine. Good, I have that right. The cosine of 60 is the adjacent over the hypotenuse, which matches the sine of 30. So the cosine of 60 and the sine of 30 happen to be the same, which makes sense because they use the same sign. But for 60 degrees, the adjacent is 1, whereas for the 30 degrees, that was the opposite. So that means the sine and cosine switch between them. And so here I'll put that the 1/2 is equal to the cosine of 60 degrees, and up here I can put that. So these two simply flip. They switch. Now, we want to explore a relationship to the others because, and actually I guess I'll wait till we get the 45s in here. But here is a quick preview that this 60, these two, it matches for this one, and it matches for this one, and it matches for this one. The only difference are going to be the signs. So knowing this one gives you 3 others automatically, you just have to watch the signs. All right, I suppose we could write that in since I just said it. Let's go ahead and do that. Negative 1/2 and square root of 3 over 2. So I don't have to do any calculating for 120 degrees. I just take the 60-degree amount and put it right there, but I have to make the x value negative. So in a few moments I'll put one in for the 45s, but let's come on down here to the 30 because you see this was a reference angle of 60 degrees, so it matches that. The reference angle of 30 will match the reference angle here of 30. So over here that's 1/2. That's the square root of 3 over 2, but it's negative. So that's the x and y for that one. Down here, this is the reference angle of 30 degrees. That'll match that, but they'll both be negative. So we'll have a negative 1/2 and a negative square root of 3 over 2. Down here, I'll put the square root of 3 over 2. Oops, but that has to be a negative and a negative 1/2. So now that one with the 2 negatives matches this one and matches this one. And it'll match this one, but here only the y value is negative. And over here, that matches this one, and it matches this one, because it's a 30-degree reference angle, but now only the y value is negative. All right, so 30s and 60s all around, we have those done. Let's do the 45s. And once again for that, down here. Now, this is not required to do. If you just have the numbers memorized, you can use that. But if you don't remember them, or if you think you might be mixed up, or if you want to be safe and careful, this is very useful. Okay, here the relationship was 1 square root of 2. So if this was 7, that would be 7, and that would be 7 times the square root of 2, which would be, I don't know, maybe about 12 or 10 point something, 11 point something, something like that. But we would want the exact number. So right now I'm just going to leave it as, if this is 1, then this is 1 times the square root of 2. What that tells me now is that the sine of 45 degrees, say this one, is the opposite over the adjacent, 1 over the square root of 2. Easy. And the cosine of 45, well, of this one would be the same, because if you do the adjacent, that happens to also be 1 over the square root of 2. So sine of 45 and cosine of 45 degrees. The only problem here is that we're not allowed to leave this in that form. You may not leave square roots in a denominator. Therefore, we have to rationalize this in order to make it the correct form or format. So square root of 2 over 2 is the sine of 45 and the cosine of 45. So come on up and put it up here. Square root of 2 over 2, square root of 2 over 2. And that's going to match all of these others. Let's put them in and just simply add the negatives. So negative square root of 2 over 2 and square root of 2 over 2. In this quadrant, it's negative square root of 2 for the y and negative square root of 2 for the x. And over here, the x value is square root of 2 over 2, and the y value is negative square root of 2 over 2. Knowing those is going to help you enormously in trigonometry, especially with some of the next level when you start dealing with identities and certain formulas. There will be times when being able to use these quickly and easily will help you, and therefore knowing the unit circle, knowing how to find them, and have the negatives correct will be a great deal of help. What we have done now is 2 of the 3 things that have to be done for the unit circle. In fact, let me summarize those up here. The things to do are must be able to do. 1 is the 16 points, or actually no, the 16, yes, the 16 angles, I should say. The 16 angles. And I'm going to put the number 17 there just to remind you that this one has 2 numbers for it. Second, 16 coordinate points. And that's what these are, an x and a y for each one of the 16 points here. Okay, this one doesn't have 2 this time, it just has the 1. And the third thing is actually 16, I guess it's, yes, it's 16 radian measures. And that's what we're going to do next. That's the last part of it, because we now have the first one, the 16 angles, with 1, 2 names, the 16 coordinate points. Next we're going to do the 16 radian measures. What a radian measure is the arc length here. And that's part of what you've already learned, or should, or if not, this will be a nice introduction. But a very quick one as far as the basic meaning. The arc length starting here, so there's a certain amount here, a certain amount to here, a certain amount to here, and so on. Because the circumference of this circle is 2 pi, it's 2 pi r, but remember that this distance is a distance of 1, so 2 times pi times 1 is 2 pi. Therefore, we're going to go 1 time around the circle and say that the radian measure here is 2 pi. Now, It's also the same as 0. If we haven't even started yet, then there's been 0 radian measurement, so it's also 0. 0 and 2 pi are essentially the same, but in this case, writing 0 isn't as essential. Here I must have it. Here I don't have to have it. 2 pi is essential. If you put 0, that's okay too, but it's really not essential. So I'm going to tell you, don't worry much about it. Just know that if you've told 0 radians, that's right at the beginning. Now, because it's 2 pi, then half of that is 1 pi, and half of that is half the circle. So 180 degrees is pi. Part of why that's true is because of the idea of the measurement. Take a look in the idea here that this is a measurement of 1. All right? So if I use this post-it note, that's a little bit less than 1. If I take that measurement and start here and go around the circle, and then go a little bit more, that would be about where 1 is. So this arc matches the unit 1 right now. And if I were to do it again, it would bring me to about here. And if I do it again, it brings me to about here. And then the extra little difference is 0.14. 1, 2, 3.14. 3.14 you've heard before. 3.14, that's why it's pi. And that shows you that this actually, if you put it in numbers, matches the amount, the units going around here. And we're then going to find the units at each of these points. Now, that's going to be easy because all you have to do is cut pi into pieces. Sounds familiar. Let's cut that one first into half. Half of pi would be simply pi over 2. Now, mathematically, you could say 0.5 pi. That's very unusual. That's not the normal convention for writing this, so don't do it. We'll write it as terms of a fraction. Let's take pi over 2 and cut it in half again. 45 degrees is half of 90, and half of pi over 2 is pi over 4. So let's put pi over 4 out here. Okay. Now, here's one way to think about pi over 4. That's 1 pi over 4. So we now know that's 1 pi over 4. If I double it, I'll have 2 pi over 4, but that reduces to 1 pi over 2. So you can't write 2 pi over 4, but that's what 90 degrees is. So this is essentially 2 pi over 4. We can get the next 45 by just doing from 1 pi over 4 to 2 pi over 4 to 3 pi over 4. So this one is 3 pi over 4. And that pattern you're going to continue all the way around. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, that reduces, 5 pi over 4 here. Then 6 pi over 4, and 6 pi over 4 reduces to 3 pi over 2. And then 7 pi over 4 here. And one more is 8 pi over 4, and 8 over 4 is 2. That confirms that we counted correctly going around the circle. This one makes me think that I maybe should have started with the fact that this was 1 pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi. So if you take a basic starting fraction, you can just simply double it, triple it, quadruple it, and keep going around the circle. So we now have, based on that, 1, 2, 3, 4, 5, 6, 7, we have 8 of these radian measures that we need. Now we need the other 8, and those are based on 30 degrees. It's 30 and 60, but 30 is half of 60. So all we need to do is find 30 and double it to get 60. Triple it to get 90, but we already have it. Quadruple it to get 120. Quintuple it, I'm not sure what the best word is for 5 times, but this would be 5 of them. And then 6, and then 7, and then 8, and then 9, and then 10, and then 11, and then, 12. Okay, well, let's see what happens when we do this. So, take the fact that this is pi, and 30 degrees is 1/6 of that. Well, 30 over 180 is indeed 1/6. But think of it this way. Here's one, well, first if I cut this here, and then I cut it 1, 2, and that one, and that one, and that one. If I cut it into 6 pieces, the basic beginning one is 30 degrees. So this is 1/6 of that. 1/6 of pi is pi over 6. That's 1 pi over 6. Come to 60, and that's 2 pi over 6. But 2 pi over 6 would reduce, I'll write it this time and then we'll reduce it. 2 pi over 6, well, that becomes 3. So in reality, it's equal to pi over 3. So you don't need to write that when you're doing it for me, but you do have to write that. So that's pi over 3. So this is 1 pi over 6, 2 pi over 6 reduced, 3 pi over 6, and 3 over 6 is pi over 2. So 3 pi over 6. This one's 4 pi over 6. But 4 pi over 6 reduces to 2 pi over 3. But since that really was 4 pi over 6, we come here and it's 5 pi over 6, and that one doesn't get reduced. 6 pi over 6, which is of course just pi. 7 pi over 6. 8 pi over 6, but that reduces to 4 pi over 3. 9 pi over 6 is already reduced to 3 pi over 2. 10 pi over 6, but then you have to make that 5 pi over 3. 11 pi over 6. That 30 degree and 60 degree ones may be for most people the most complicated part of it. So what I recommend that you do is to practice thinking of it as one of these and then count around, even maybe write it out as 2 pi over 6, 4 pi over 6, 8 pi over 6 if you need to, and then reduce it after you write it. But if you remember it as a pattern, starting with 1 pi over 6, then going to 2 pi over 6, then 3 pi over 6, that will help you get the exact correct fraction at each of those places. And you don't have to memorize these. In fact, based on what I've just done here with you, you really only have to memorize this. And this doesn't take that much memorizing if you just think of it as 1/6. So you have to memorize that, but memorizing that, this shouldn't be hard to memorize. This is based on the 2 triangles, the special right triangles that you don't need to memorize, just the ratios. And these are based upon the pattern of starting with pi over 6. And the basic idea that this is 2 pi around the circle. So what you have to do, and I'm going to do a little line here because that part was just work to help us find the sines and cosines. You have to be able to write 16 angles, which you can, one with 2 names. You have to put 16 coordinate points, the x's and y's, which come from these right triangles and from the basic graphing points. And you have to be able to do 16 radian measures based on the fact that a unit circle has a circumference of 2 pi. And following the pattern starting, I recommend with 1 pi over 6 and here 1 pi over 4. That's a completed unit circle. That will hopefully help you with writing it out for any test and any use that you might need.